Hello everyone. Hope you all are doing good. Welcome to the chapter 10, our last chapter. And after this chapter, I'm going to go live maybe in the coming days. Of course, maybe definitely in the coming days from tomorrow on to do the labs for you and finish up all the labs. So let's finish up this one chapter today. That is chapter number 10. So let's see, that is device discovery, management, and maintenance. So in this chapter, this is a different type of chapter. We aren't discussing just one topic on this one. We are discussing actually several topics, okay? We're discussing several topics, how to maintain the router, how to back up the image files, how to do a password recovery, how to set times into the router, all kind of maintenance, how to check the error messages saved in a Syslog server, things like that. So let's go and start with this 10.1.1 CDP overview. Let's start from here. So we're gonna again discuss many different topics, small topics, okay? And just basically learn how to do this, how to do that, how to troubleshoot, how to save, how to back up, how to restore from the backup. So it's interesting, easy. And we're gonna be selectively discussing some topics I won't even discuss. CDP we are going to discuss. It's called Cisco Discovery Protocol. What is it about? A Cisco Discovery Protocol, what it does, if you have a Cisco device like a router or a switch, and then you have many other Cisco devices, they are connected to it. From this one device, you are able to find out other devices. For example, this is the router. So you are logged into the router. You are consoled through the console port or through the remotely, or however you are connected to this router. Once you are connected to this router, you go to the privileged exec mode and you type the CDP command, show CDP neighbor. And what you will see, you're going to see that, hey, this router is connected to another switch. The model number of that switch, what port of that switch is connected to this router, and to which port of this router. You are going to have all this information. What type of device is it? Is it a switch? Is it a router? What is capability? You may have many more routers and switches connected to it. You're going to see all of them. So if you are in New York and your router is in Dallas and you cannot physically see what other devices are connected to this router, CDP would be a very handy command, very handy protocol. Okay, so let's talk about let's see how it works. Okay, you go to the router's privileged exec mode and type show CDP, that command. Okay, if the CDP show CDP, we're not talking about show CDP neighbor yet. So I'm not seeing neighboring devices yet. I'm only seeing whether the CDP is running on my router or not. Okay, so this one I only typed this command show CDP. Again, CDP means Cisco Discovery Protocol. This protocol runs on the layer 2. A little bit about this protocol. Layer 2 means data link layer. Okay. So even if you have, you are logged into your router, and that router is again connected to many more routers and switches and so on. Now, those those connected routers and switches, say they even don't have their IP address assigned yet. So you cannot even telnet to them, cannot even SSH to them. But via CDP, from this one router that you logged into, via CDP, you can find out all about those routers and those switches, where they are, how they are connected, and all of those. It's very cool. Now, if you see that CDP is not running, then you would be typing this command CDP run. Okay, then CDP would be running. CDP protocol would be running from that point on. If you do not want CDP protocol to run, what happens when CDP protocol runs? Routers and switches, all the Cisco devices, they start talking to each other, sharing information about each other. That's called CDP advertisement. So they actually advertise to each other that, hey, I am a switch and I am my gigabit 01 port is connected to your gigabit 00 interface, and so on. So, and I am a switch of 2960 model number, things like that. My IP address is this. All those information, they start advertising, sharing with each other, okay, when CDP runs. If you did not want the CDP to run, again, in the global config mode, you type no CDP run. This is the command right here for you, okay. Now, that is again for the device as a whole. If you want it to run CDP, again, you type CDP run in the global config mode. If you do not want the CDP to run, you type no CDP run, okay. Having said that, if you say that, okay, I have CDP is running, but in this router, I have several interfaces. I have gigabit 00, I have gigabit 01. I only want CDP to run the gigabit 00 interface, not on the gigabit 01 interface. Don't send any advertisement via this gigabit 01 interface. Yes, you can do that. You can select some interface to send the and receive the CDP advertisement, and some other interface you can configure that it's not going to share the CDP advertisement through. Yes, you can do that. What you do in that case, you go to that interface mode, and in there you type no CDP enabled, as you can see in the picture, in the slide right here, and that is on each individual interface. CDP enable right here, or no CDP enable. That's how you configure each interface if you wanted to configure each interface separately. Again, not to be confused, for the whole router as a whole, if I just type CDP run, it's going to run on every interface. Then if I decide that maybe some interface should not run, I'm going to disable on some interface, so CDP should not run on the serial 000 per se. Then I would, on that interface, I would type no CDP enable, okay? So, and so that goes. And then how do you see CDP right here? On a particular interface, you type CDP enable or no CDP enable, okay? Now, in the global config mode, you can type CDP run or no CDP run. So here is CDP run and here is no CDP run. Enable the CDP or disable the CDP. Simple, very simple things in this chapter. Now you are seeing what devices are connected to your router or your switch. In this case, you are in the router and you are typing show CDP neighbors. Once you type show CDP neighbors, it is going to show what other devices are connected to your router. And good to know of these things. R means router, T means transbridge, B means source route bridge, S means switch, and also on. You're going to see this I for IGMP. So when they show that there are some switches here, it's going to show the capability of the device. You're going to see it's going to say S and I. That means this is a switch and this is IGMP. Okay. Now next, show CDP interface. Okay. If you type that command, another show command. So they're just teaching you several show commands. You're in the privileged exec mode again. So show CDP neighbors, we have just done that one. Now we're doing show CDP interface. Then it goes to one by one interface, like Ethernet 00, gigabit Ethernet 00, then gigabit Ethernet 01 right here, look. That one is up, line protocol is up. On the 01, serial 00 is administratively down. So there you have several interfaces, gigabit 00, 01, serial 00, all the interfaces one by one showing about CDP. Gigabit 001 is up, sending the CDP packets every 60 seconds. Hold time is 180 seconds. Okay, so because the CDP is enabled in this device, every interface by default will have CDP enabled. Okay, next screen. Now they want you to practice. Display the status of CDP on R1. Well, in that case, you just type show CDP. So click on show me. Look, show CDP, that's the command. Okay, and then all these things you can click on just show me and you can find out. Okay, so in the config terminal, you're going to type CDP run. That way, CDP is going to run on the global. So anyway, you can practice those. Very simple things in this chapter. Discover devices using CDP. Again, your command will be show CDP neighbors. That's your command. You can also type show CDP neighbors detail. In the detail, they're going to give you more details about it, like an IP address and layer 3 addresses and all those. So show CDP neighbors will, for example, this is a good screen to look at. Device ID S1. So you are in the R1, you are in the router right now. You do not know what device is plugged in to your computer, right here, question mark. You don't know what that is. So you are in the R1, you are in the router, you are in the privileged exec mode, and you type show CDP neighbor. So then this other device that is plugged in shows up in here. Device ID S1. So you think, oh, okay, that name of the device is S1, but that's the only host name. What kind of device is it? It shows capability S and I, meaning it's a switch, and I stands for IGMP, okay, interior gateway management protocol. So now IGMP right here, then you have the platform. What type of switch it is? It is a 2960, that kind of switch. And your port ID is the fast Ethernet 05. So that switch is connected to you. Switch's fast Ethernet 05 port is connected to yours gigabit 01. Local interface is your interface, your port. So this switch is plugged in to the router. The router's gigabit 01 port is connected to switch's fast Ethernet 05 port. Okay, so that was the command, show CDP neighbors. We can also see show CDP neighbors detail, and look at this right here. They're teaching you right here what each of those term means. Device identifier, that's device ID S1, that's the host name. Port identifier, so your local port and that device's port, both of them are shown. Here is your local port and here is that device's port. Okay, both are shown in here. Capabilities like S for switch, I for IGMP, things like that. Platform, the hardware platform, like what type of switch, what model of switch that is. Okay, that's it. And show CDP neighbors detail, let me see, right there, look, show CDP neighbors detail. That shows a whole lot more information. Even shows that this switch has an IP address, 192.168.1.2, even shows all of those things and more detail about that device. Okay, and going down more, that much it shows. Okay, next screen, show CDP neighbors. Again, you have more devices. Here is one device, here is another device, another router right here, question mark. And see, this other router is not directly connected to my router. It is connected to this switch, but I am seeing them R1 coming up also. Interesting. So CDP is a useful command and is useful protocol. Okay, next. Okay, now we talk about LLDP. So far we talked about CDP. CDP means again Cisco Discovery Protocol. Okay, that's Cisco Discovery Protocol. So it only runs on Cisco devices, not other devices. But your router and your switches and all the networking devices, for those, Cisco is not the only manufacturer. Cisco is not the only brand. You have this Bay Network, you have this so many other brands, Linksys, whatnot. Linksys now, of course, Cisco, D-Link, many other brands in the world that may make similar device. Okay, so if you have some other networking devices, switches and routers, they are not Cisco, then they would not run CDP. But could you discover them? Could you find what devices are connected to your router? Yes, you can. It's a different protocol. That one is called LLDP. Okay, that is Link Layer Discovery Protocol. LLDP. Okay, Link Layer Discovery Protocol. This one is vendor independent, meaning whether it's a Cisco, whether it's HP, whether it's a Bay Network, whether it's a Nortel, doesn't matter. Whatever brand you have, your devices, they all would run LLDP. Okay, Link Layer Discovery Protocol. Very similar to CDP. Okay, so what it does, it's a physically connected layer 2 devices. It will report that, hey, it's connected to this switch, this other router, and so on. Just remember that this is vendor neutral. Okay, it doesn't matter who makes the device. Next, how do I configure and verify LLDP? We learned how to do CDP. How about LLDP? Same way. We had CDP run, now we have LLDP run. If we do not want my device to run LLDP, then I would do no LLDP run, just like we had done no CDP run. So now LLDP run and no LLDP run in the global config command. Okay, right here. Config, I have typed LLDP run. Okay, and then one particular interface, I can type LLDP transmit, LLDP receive. Okay, LLDP run, I type that one on the global config mode. See, config, okay, and in an interface mode, interface gigabit Ethernet 01, on that particular interface, I could do LLDP transmit, LLDP receive. Okay, so, and then how do I verify that LLDP is running? That is show LLDP. Just like show CDP, you got show LLDP. Okay. Okay. Display the status of LLDP. That will be show LLDP. Right there, show LLDP. See? And then you can practice more of these commands. Simple enough. Okay, next. Discover devices using LLDP. Just like we did show CDP neighbor, now we'll be doing show LLDP neighbors. Okay, show LLDP neighbors, and it shows same way, these devices capability, router and a bridge, things like that. Okay, R means router, B means bridge. This is the vendor independent, not the Cisco type. So it's more simple. Okay, next. And show LLDP neighbors detail. In that, you see more details on these particular devices. Okay, simple. Okay, let's do this activity together. Okay, so we have some characteristics. We have to choose whether this is for CDP or this talks about LLDP. Okay, check the appropriate field next to each characteristic to indicate your answer. Used, the first one, used to gather information about Cisco devices. Of course, Cisco devices, CDP, no question. Advertisement share information about the type of device that is discovered, the name of the devices, and the number and type of interfaces, CDP. Works with network devices such as routers, switches, and wireless access points across multiple manufacturers. That's your key. Multiple manufacturer cannot be CDP. CDP is only Cisco. So this is LLDP. Okay. A vendor neutral, right away. A vendor neutral, that means any vendor. That's LLDP. Okay. Now, media and protocol independent, runs on all Cisco devices, or all Cisco devices, CDP. Okay. And then this protocol advertises its identity and capabilities to other devices and receives the information from physically connected layer 2 devices from multiple manufacturers, LLDP. Okay, check. Yeah, we got them all correct. Okay, so if it's only about Cisco, it's CDP. If it's multiple manufacturers or vendor independent or vendor neutral, then it's LLDP. Next. Okay, now we're talking about a different topic, that is setting the system clock. Okay, system clock. Why would we want a system clock? What is clock about? We can see our time from our cell phone, from a clock on the wall or on the table. Why do I need in the Cisco router a clock? Well, this is not for checking time. This is very important. Any event that takes place, the router reboots, something went up, an interface went down, something happened to the router got an error, you want to know exactly what time that happened. For an example, so the router has to give you the exact timing for important events to take place, to configure something that you want to schedule to happen. So it's very important that router has time. Router knows what time it is, what time of the day, year, month, minute and second and everything. Just imagine you have so many different routers, a few hundred routers and switches, network devices in your company. And each one has a little different clock. They are not synchronizing properly. Okay, like some says right now is 10:28, some says it's like 10:25, some says 1:23. Now, if you want to have an event to take place, upload something, download something, reboot something, upgrade something, any kind of event, or something had taken place and you wanted to investigate what time it took place, what time this interface went down, and your time is all over, that will be a mess. Therefore, it's very important that all your networking devices keep the right time and they are synchronized. Okay? Two ways to set the time on your router. And the two ways are, number one here, manually configure the date and time. So you can use a command called clock set right here. That command, clock set, and then you type hours, minutes, and seconds, and then month, date, and year. Okay, that's one way to do it. Manually, you go to the router and type this command, and you set the time. From that point on, it's going to have that same kind of time. So this time is going to set in this moment, at this moment, this time, and then it's going to continue from there. So you set the time for this moment as this. So that is manually you configure by this command. Another way to do it, that's a better way to do it, is configure the network time protocol, NTP. With network time protocol, all your networking devices will be connected to an NTP server, so that one router in your company is going to be the NTP server, and all other networking devices will synchronize their time with that one server. So that's enormously beneficial. Number one, you don't have to go to every router and separately keep on putting your time. And also, then again, after doing so, your time may not match. Maybe 1 minute, a few seconds would be different from each other. But if you configure your NTP and every device is synchronizing its time with this NTP server, then all your routers and switches, all your networking devices will have the same time. That's going to be fantastic. Okay, so we're going to learn how to do all of those. So first, you see how to do it manually on each router separately, each switch separately. Is this clock set, and then hour, minute, second, month, day, year. Okay, now next. Now NTP is an interesting thing. In the world, there are some GPS clock. They are authenticated clock. They are authoritative clock. Those clocks are kept at a certain strategic location in the world, and whatever those clocks say, that is the authenticated time. That is authoritative time. Okay, your time could be wrong, but that time, whatever that clock says, that is secured place and secured clock in a way that it does not mess up. So other networking devices like a big ISP like AT&T, like Verizon, big telecom, billionaire companies, they have their special NTP server. Their NTP server will be synchronizing its time to these main authoritative clocks. Okay, the word stratum means layer, as you know, layer of, this is one layer, the first layer, stratum 0 or layer 0. Okay, then the next would be the big companies, the big ISPs, the NTP servers. Those, and again, NTP is what? Network time protocol. So they have a server machine that is, its job is to keep time. So this NTP server machine is connected to that authoritative stratum 0 clocks. Then smaller companies, they are going to have their router or their switch. They will be connecting to this stratum 1. So as you go more smaller and more detailed, then you have from stratum 0 to 1, 2, 3. I think you can go up to like a stratum 13 or 15. Okay, 15. Okay, from 0 to 15, that means total 16. A maximum hop count is 15. Okay, so stratum 16, the lowest stratum level, indicates that a device is unsynchronized. So it could go up to 15. That's maximum hop. If you see the status of the NTP and you see that you are actually stratum 16, that means you are unsynchronized. You are not being synchronized with anything. So you got to synchronize with an NTP server. By the way, in your company, you can set up one router as a stratum, as a NTP server, and it's going to show, if you see the status of it, of NTP, then you're going to see it shows your stratum what. You could be stratum 2, you could be stratum 1, it could be stratum 3, whatever, okay? And there are some publicly available NTP clock over the internet. You can connect with them. So you know, there are some publicly available. So those NTP servers, any company's router can connect, and then the rest of your device will connect to your NTP server. Okay. So again, you are going to designate one router or one server machine or one switch or whatever that you have, that your device as your NTP server, and synchronize your NTP server to your ISPs or some internet-based authenticated NTP server. And the rest of your devices will be taking time from your server. Okay? Okay. Next. Now configure and verify NTP. How do we configure NTP? These are all easy, simple commands. Okay? Here you have an NTP server. This switch S1 is acting like an NTP server. So this computer, whatever you have, could be an NTP client. This other router could be an NTP client or could be an NTP server. Here is an NTP server. Okay? So all these devices can be set either to be a server or to be a client. Now, if you type, just to see the clock, show clock detail 1, it's going to tell you first of all what clock it is right now, what time, what day, what year, that. Then it says time source is user configuration. That means you are not doing NTP. You manually set up time clock in this switch, or in this case, in this shows the R1. So this one right here. In this router, you are manually setting the time. Your router is not synchronizing with NTP server. Then you go to the global config mode and you type NTP server and the server's IP address 225. See, there's an NTP server available in the internet. So you configured your router to synchronize with this server machine. That's how you do it. Simple command, NTP server and the IP address of that server. And click on end, you're done. Now you show clock detail. Now it shows time source is NTP, network time protocol. Okay, so that's how but how do you do check the NTP? Yes, you can use the show commands. Let's check. Show NTP associations. That's a command. It is a show commands to verify NTP. Once you type show NTP associations, you see this address. That is your NTP server. Reference clock GPS. Okay. Your stratum is 1. Think of that. This is a stratum 0 server, authoritative main clock, GPS clock server. And you are connecting to that one. So your router is stratum 1. Okay? It's very high level because you are connecting to the stratum 0 server. And then some other more information discussed in here. Now you also type show NTP status. So what did you type earlier? Show NTP associations. You can also type show NTP status. The clock is synchronized, stratum 2, reference is this. Okay, so you will see. So right here. So no, in this case this one right here 209, that is the stratum 1. The 209 is the stratum 1. So your router is stratum 2. Your router is stratum 2. So this clock NTP server right here, this 209.165.200.225, that is stratum 1. And it is connected to one of those clocks, authoritative clock. And your router's status right here shows with the status command, that is stratum 2. So you are the third tier, okay, and shows a whole lot more detail. Next. Now, if you want to set up your router or your switch, for example, as an NTP server machine, this is going to become a server to so that other devices can be its client. Then all you have to type that in this case dot one. Okay, dot one is the router. So in this case, in this example, S1 is being your client. S1 is not being a server. S1 is being a client of this router. This router's IP address is 192.168.1.1. That's your router. Okay, and then a switch, you are configuring it as clients. You are in the S1 switch. You're saying NTP server 192.168.1.1. So telling the switch that, hey switch, I have an NTP server right here. That's that router. So synchronize your time with this router. So all you have to type NTP server and the IP address of the server. That's it. And then end. Show NTP association shows now about this R1 router. Is that its IP address is this, its reference clock. This one is getting the reference from this 209, that one, this other server. So again, your server, the S1, you are in the S1, your NTP server is R1, this router. And this R1's NTP server is this 225, this person, NTP server. So this R1's stratum is 2 right here. That means what? This S1, your stratum would be 3, and that shows right here, stratum 3 in the switch. When you do your status, when you do show NTP status, that command, then it's going to show your own status, which is stratum 3. So see how it goes? Let's summarize it. This one, NTP server here, its stratum is 1. Then my router here, I configured it as a NTP server. So it synchronizes with its higher up, this .225, this computer. So this NTP server, its stratum is 1. So my R1, its stratum is 2, and my S1 depends on my R1. So S1, its stratum is 3 right here, okay, and so on. And so if I have many other devices, they all are going to connect to this R1, and everyone is going to have stratum 3, just like this S1. S1 is one of them. I'm going to have another S2 here, S3 here, another router, another switch. All of them, they're going to all have this stratum 3 because they all are going to connect to this R1, okay, for the timing. Okay, next. Okay, now they want you to learn how to do show clock detail, how do you do the NTP server and all those things. You're going to be doing it. Configure terminal. So just learn those things. Time clock. If you're manually setting the time, that's how you do it. Here you're doing all manually. Okay, just practice those commands. Next. Packet tracer configure. Next. Now we talk about another topic, something called syslog. What is syslog? What is log? First of all, log means when an event takes place, it keeps a record. Okay, the Cisco devices, routers and switches, networking devices, computers, even our PC computers, they all have their event log. Where any kind of event takes place, they are logged. For example, I'm in my computer, I'm in my PC. If I type event, EVENT, just to give you an example, okay, event viewer, I go to the event viewer in my own PC, and I can see these Windows logs. There is application log, there's security log. See, this is setup log, system log, all kind of log has happened. Look, these ones, YOLO is warning. Okay, if some serious error happens, they would be like red color. Okay, right here, look, error happened. It shows exactly what time, what kind of error. Once I click on it, in the bottom here, it shows all the detail what it was about. So every device, computer, router, switch, they have their event log. Okay, Just I wanted to show you. So Cisco routers, Cisco devices, they too have their event log. Now, where should these devices store their events, this log? So you, the network administrator, can go and view the event log and see the logs, find out what's going on, what action to be taken. If something critical error had happened, something went shut down, something very worthy of your attention happened. So you need to know those, or something simply a debugging or is just a warning that kind of event has taken place, okay, or troubleshooting kind of, not very critical. So Cisco has this kind of events takes place. So you could actually configure a machine, a computer, a server as your Syslog server. So all the routers and switches, you don't have to go to each router and each switch to find out its event. It will be so strenuous and unproductive and difficult to manage all the logs that are going to remain to each device. So that's going to be seriously cumbersome job for you to find out what happened to each device. Instead, you're going to channel all the events from every device, all of them come to one machine, and you're going to have a special software, okay, some kind of event viewer, event log viewer. There are so many softwares like Syslog, we call them Syslog software. That kind of software you're going to have installed, a Syslog server installed into that server machine, into that PC or that computer, okay? So that across your network, anything happening, no matter where it is happening, which router, which switch it is happening to, they're going to all come to this one computer. So you can see from one location, all of it, okay? That's what we're talking about. That's your Syslog. So the Syslog logging service provides three primary functions. The ability to gather logging information for monitoring and troubleshooting. So all are going to gather into one place. The ability to select the type of logging information that is captured. You can configure it that, hey, only capture this kind of log. Only check the critical error. Don't save the debugging information. Okay, the ability to specify the destinations and capture syslog. So you can configure so many configurations you can do in the server. Has many advantages. Okay, next, Syslog Operation. So this system log messages. You have noticed that when you are in the packet tracer, you issue the no shutdown command to an interface, and it gives you a log message that shows up. Says that the interface gigabit Ethernet 00 just went up, okay? The line protocol is up, the line protocol, the system is up, line protocol is up, things like that. Those are log messages. That log messages can be saved into your own logging buffer. It could display in your console connection. It could also display in your terminal line. Okay, like you are remotely logged in and you are seeing those log messages. In the console is you are locally logged in, locally connected to the router or switch and seeing, or they all can be sent to the Syslog server machine. With an IP address, everything is going to go to that computer, okay? Okay, so it shows right here that in the logging buffer, you can save there. In the console line, it can display in your console connection, it can display in your VTY connection terminal, or it can be sent to a server machine. Okay, next, Syslog message format. What you need to know for your exam and for everywhere, this is extremely important information. You got to sort of memorize this one, at least have a good understanding that when you see a particular log message, how important it is. There is a security levels, okay? Level 0 to level 1, level 2, 3, 4, all the way to 7. Level 0 is the most emergency, most important. That one is emergency. If you see a level 0 message, something happened to your machine that requires your immediate attention. System is unusable. Your system has been shut down, system has been unstable, frozen, whatever. Okay, then alert is level 1, immediate action needed, critical condition. Number 3, level 3 and level 4. So between 0 to level 4 are the most important ones, my friends. Level 4 is a warning. Okay, just remember this. Between level 0 and level 4 are the most important ones. From warning to error to critical to alert to emergency. And then these other lower levels you have, that is level 5 is just a notification, something happened, easy, simple, normal, something happened. And then informational, level 6, and then debugging, level 7. This kind of 5 to 7 are not as important. Okay, so now, and it shows all this explanation for you right here. Okay. Common syslog messages facilities reported on Cisco iOS routers include IP, OSPF protocol, sys operating system. Operating system is your sys, okay, and IP security, IPsec, okay, and interface IP, IF. These kind of message facilities, okay. We'll discuss what is a facility, because when you look at a line of the message right here, look, you need to know this. A whole long line that shows up, first thing is going to be a sequence number, then would be a timestamp, then would be a facility, okay, like what type, what is talking about. It's talking about security, talking about an interface, okay. Then severity, that's going to be the level. It's going to say level 0 or 2 or 3 or whatever, okay. Mnemonic, okay, also what is happening, more specific. And then the description, exactly what has happened. And here is an example. For example, look at this. This is your timestamp, okay. This is your facility, link. Link is your facility. It's talking about link. This is your level. Level is 3, meaning 3 would be what? 3 would be error, and error has happened. And what is the mnemonic? Mnemonic is up, down, okay. That's your mnemonic, remember that. The mnemonic is up, down. And then interface. So if somebody says, what is mnemonic? Meaning, what are the options? Mnemonic is your options within this link facility. About link, what could happen? Up could happen or down could happen, right? Those are the mnemonics, just remember that. That's more specific to this link. Then exact description, that interface, port channel 1, changed state to up. So again, one more time, we're going to talk about this. This is going to be, it's part of your exam, you need to understand, and sometimes they're going to give you a log message, a whole line, and they want you to identify which one is what, which portion tells what. Again, first is sequence number. In this case, I did not have sequence number because it is not configured to have sequence number. Then you have timestamp. Sometimes you may not have timestamp if you didn't configure it. I want you to know that. Sequence number, timestamps will not be there unless they are configured, okay? But the facility will be always there. Facility is what it is about, okay, what topic, and then the level, okay, the emergency to debugging, 0 to 7. Then mnemonic, that's going to be always there, and the description, they are going to be always there, okay. The most common messages are link up and down messages. The messages that a device produces when it exits from configuration mode. Yeah, you see that all the time when you configure something, get out of the global config mode, and you see some message, some log shows up, okay. So look at this. Again, I'm going to go here. Sequence number, that stamps log messages with a sequence number only if this service sequence number that is configured. If it's not configured, no sequence number will be shown. Timestamp, also this is optional. The date and time of the message or the event, which appears only if the service timestamps global configuration command is configured. So service sequence numbers and service timestamps, if they are configured, then those will show up. But the facility refers to that which facility the message is referring. Severity is the level, mnemonic is the text string uniquely describe the message, and then the description, okay. Okay, so next, okay, how do I configure now service timestamps for my log messages? Okay, here is the command: service timestamp log date time. Okay, so that's your command. Look, service timestamps log date time, that's the command. If you use this command in the global config mode right here, okay, then a timestamp will be shown. And look at this example right here. This is a nice example they showed you here. Interface 00, you shut down the interface and a log message appeared. It did not have any timestamp on it. It didn't say what time it happened. So you went ahead in the global config mode and issued this command: service timestamp log date time. Then again you went to that interface and it did no shutdown, so it came up. This time it shows the time. Okay. Okay. Next. So let's see if we can identify. Okay. Here is a message, log message in the black and white. If we could identify each portion of it, let's see if we can do that. Instruction: read the syslog output shown. Here is the syslog output. Drag the output to the field next to the appropriate identifier. Not all options will be used. Okay. Sequence number for this syslog entry. Okay. So the sequence number for the syslog entry, and then severity level, the mnemonic, the entry timestamp, and the syslog reporting facility. Okay, so let's see if the sequence number is there. Okay, so this is the timestamp. Sequence number is not there, so I'm going to say no entry listed. Okay, severity level of this entry 7 right here, because you see this is your facility right here, IFMGR, that's your facility. 7 is your level of severity, and then you have your mnemonic, this no index, no IF index file, and this is your description. Okay, okay. Now mnemonic for this syslog entry, mnemonic is no IF index file, so that's your mnemonic. Entry timestamp for this syslog. Okay, yes, timestamp is there, this June right here, that's your timestamp. Okay, syslog reporting facility, facility is this IFMGR, that's the facility. Okay, IFMGR. Okay, let's check. Correct. Okay, so I want you to know this one. Why did I know that the identifier, the sequence number, is not there? Because sequence number should be before the date stamp. So I saw that before the date there was nothing in there, so there's no sequence number was in there. Okay, so then from the June to all the way to here, I have, this is my date time stamp, so the entry stamp, I got that. Then we have this part is most important for you. The first one here is facility, second one is here is your level, third one is here is your mnemonic, and the last one is your description. Okay, so I want you to yourself go ahead and practice by at home the number 2, number 3, practice them. Next. Okay, Syslog Server. This is just showing an example. The Syslog Server actually is a software. Okay, that software you got to download into your machine, your PC or your big server machine, where then that PC or that big machine becomes your Syslog server. So all the routers and switches, networking devices, they are going to send their log into your Syslog server. And this Syslog server, this software has a beautiful way, it sorts everything, it can generate reports and all those things. So you got to download this software as a free trial, like this one is 30-day trial. This is a QE Syslog server. That's the one they're showing you in here. This QE Syslog daemon, that one you can, for the Windows, you can download it for free, 30 days trial, and see, look at it, if you have time, play with it. And it's going to show all kind of this TFTP server, TFTP client is going through the trivial file transfer protocol. Okay, so TFTP D32, that's also another software that you can download. Then it becomes a TFTP server. So the Syslog, all the log from the routers and switches and everything is going to go to your TFTP server, meaning goes to that machine where this TFTP server is installed, where this Syslog is also installed. So this is a separate software, not to be confused. Syslog, this logging server, that is one software. This other software called TFTP32, TFTP-D32, that is also another software that you install in your machine. Then your machine becomes a TFTP server, so that all the routers and switches, they can access you. They can send to TFTP with your IP address, and everything is going to come to your machine. Okay. So anyway, next. I don't think that many of these things actually you're going to do at home, but at least get the idea. Okay. Now, show commands. Okay, the default logging. So the logging buffered, to enable those two settings, what happens by default, the log is going to go to the logging buffer. Okay, you have the memory buffer in the RAM there, and you're going to also, as you are working, the message is going to pop up automatically. That's your logging console port. Okay, so normally this is what's going to happen. By default, Cisco routers and switches send log messages to all severity levels to the console. Yes, that's why whenever we're in the console, always we're typing something, some log message pops up. Okay, and so the device also buffers the log messages by default. So if you did not do any kind of TFTP configuration, nothing, syslog, nothing, you didn't do any of the Syslog server, nothing, automatically by default is going to be putting in the buffer and also going to show in the console connection. Okay, just know that. So you click on show logging and it's going to show the detail of it. Show logging is your command. Okay, next, router and switch commands for Syslog clients. Now if you want to become a Syslog clients, you already have a server machine. TFTP server is running onto that one. Syslog server is running onto that machine. Now you have to come to your router, come to your switch, and just tell your router, tell your switch that send your log messages to that server. So your router, your switch becomes a client, Syslog client. Okay. So that's how do you configure that. That's what they're showing you. So number one, in the global configuration mode, use the logging command to configure the destination host name and or IPv4 address for the Syslog. So you are going to your global config mode right here, it's an example, and you type this command called logging. And whose IP address is this? That Syslog server's IP address, that TFTP server's IP address. And then next you are going to type logging trap 4 means the level 4, meaning from 0 is the most important one, emergency. From 0 to 4 only will be logged, others will not be. Okay, like a debugging, level 7, level 5, level 6, they will not be logged. Logging source interface gigabit 00, interface loopback 0. So you just configure those interfaces. Okay. Now, so you just look at this one by one steps, and it already shows here in your example. Okay. So first of all, you did the logging command, issue the logging command and the IP address of the Syslog server. Step 2, control the message that will be sent to the Syslog server with the logging trap. Again, with the logging trap, you just put the level. In this case, we did 4, and that's pretty common. If you put 4, that means just 0 to 4, not just 4. 0 to 4 will be logged, which is very important. Okay. Remember, number 4 was what? Warning. Number 4 was warning, and number 0 is emergency. Those are important ones. Okay, 0 to 4. Step 3, optionally. This is optional. Configure the source interface with the logging interface. Then the interface type, interface number, like for example, gigabit 00, gigabit 01. Okay. Okay. It specifies the Syslog packets contain the IPv4 and v6 address of a specific interface, regardless of which interface the packet uses to the exit. Okay. So what's going to happen in your log? In your log, it's going to show always that interface, that it came from that interface. Okay. Whatever interface you specify in here as a source. So anything coming from this router, when you go to the Syslog server, you're looking at the logging messages, you're going to see it says it came from that interface. Okay, that's all it is. And again, what is this TFTP? I'm going to repeat a little bit. What is this TFTP 32? That's another software. Okay, so you can create a TFTP server on your machine. You can actually search it in the Google. You can download it for free. TFTP 32. Okay, next. Verifying syslog. Okay, you can do this show logging, all the show commands, show logging, okay, and not as important. I move on. Okay, now, okay, packet tracer, next. We're going to do all the labs whenever they show the lab. Now we go to another topic. We just keep on going topic to topic. Okay, this one is also important. File system. We need to know a little bit about file system. Remember, in the PC, in our computer, we have this file system. If I click on here, I see the file system. Okay, I see the file system in the file explorer or file manager, whatever. This is file explorer in the Windows 10. I go and see this PC, C drive, my hard drive. I go to another folder, go to the users, go to the Munshi, things like so. See what's happening? Munshi folder is in the users folder. That is inside C hard drive. Hard drive is in my PC. So the hard drive is the storage. In the C drive, I have a folder, and then inside more folder, inside more folder, inside more files and things like that. So that is the file system. File system in my PC. Same way, the routers have file system. Routers have several locations where they keep the files. Okay, and one of them is, of course, the most important one. One of the most important ones is the flash, your flash memory. That's where router has the files. Okay, another one important one is the NVRAM, non-volatile RAM. These two are very, very important for you. Look at what it shows, the size, meaning the total size of the flash memory is this. How much is free space in the flash memory right now is this. In your NVRAM, this is total size, and this is how much you have free. Okay, and then these flags RW, meaning read and write. Okay, see WO meaning write only. Okay, this is read only, RO, and things like that. Don't worry about this opaque network, too much detail for that. Just disk. Important is the disk. That anything that is disk typically would show you the size and the flash memory. This other flash one, you don't have anything inserted in that slot. You don't have another flash memory card inserted. That's why it's showing nothing. Okay, so what command did you use to see this? Show file systems. That's the command, show file systems. Okay, and once you go to the flash, but by the way, let's look at this asterisk. Why does it have asterisk? Meaning this is your default file system. Right now, if you want to type dir command, it's going to show all the files that are in this flash. This is the one is default right now. This is the one it's showing right now. Okay, what does this pound sign mean? Meaning your operating system, your iOS is installed in this flash memory, which is normal, pretty normal. Okay, so this is the flash file system, important to know. You can use the dir command to see all the commands, all the files in there, sorry. And NVRAM also has many files in it. Important file is your startup config, that is in the NVRAM. Okay, this next screen, look at this. Type dir to see all the files detail. You are in the flash. Always remember flash 0 and flash 1. There are two flash memory slots in there. I am in the flash 0. Flash 0 in colon is the directory of this flash. I have all these files. I have total 7 files in here. 1, 2, 3, 4. Each one is a file. Okay. At the last one, file number 7, look, that one is my operating system. My operating system file is pretty long. It ends with a bin, bin. It starts with the hardware platform like C1900. So it's a 1900. This operating system is installed on 1900 series switches. Universal K9, MZ, SPA, each of those terms, what it means, we'll discuss. I'm sure it's coming up somewhere in some slide. We're going to learn how to read the file name of an operating system. Okay, so just to show the content of the directory of flash 0. Okay, next. Now you wanted to see what is in the NVRAM. So what you did, you type the command cd, means change directory to NVRAM. These things you won't be able to do in the packet tracer. Okay, unless they have a special things installed. Normally, I tried this in the packet tracer, didn't work. So, but if you have a real equipment, yes, you have a real router, real switch, yes, it's going to work. So cd NVRAM, meaning you just change the directory from flash to NVRAM. Then why did you use pwd? Well, that is print working directory. Okay, pwd means just to make sure that you are in the NVRAM. Print working directory means what directory, what location I am in right now. So you are in right now NVRAM. Then you type dir and see what is in the NVRAM, and you see, oh, okay, I have so many things in here. Most important one is what? This startup config. That's of particular interest for us. Okay, next. Swiss file system. Okay, show file systems. Anything that is not, we don't have to go too much detail. I'm going to just skip. Backing up and restoring the using text files. I'm going to skip this one. This is about the backing up and restoring using TFTP. I will go on with this one. This is important. This is something we do in networking all the time as a network administrator. Look, here what you are doing, remember we used to do copy running config to startup config, meaning let the running config file be copied onto the startup config. But in this case, you are copying, because when you do that, your running config is going to be saved as a startup config. Where? In your NVRAM, non-volatile memory, in your router, in the same device. But you thought that, hey, I would like to copy it, I'd like to save this running config to somewhere else, to another machine where I can keep as a backup. Okay, in a different TFTP server machine, like a computer where you have TFTP server, like TFTP D32, that kind of software installed. So that machine, that PC becomes your TFTP server. Okay, so you can actually copy it to that machine, to that PC. So just type copy running config TFTP. Then it's going to ask you, okay, what is the IP address of the TFTP server? Then you type the IP address. That's the remote host. Okay, and what should be the file name? Okay, so you just type the name, whatever name you want to put, and then write to the file the same name. Yes, just press enter, and it's done. So the command was copy running config TFTP, and then this dialog is going to come up, unless you wanted to write down this IP address, everything all at once. But it's easy to just type the command and then answer these questions one by one, easier. Okay, that shows the steps here. Okay, so to back up, you do the copy running config TFTP. Then of course enter the IP address of the TFTP host, TFTP server. Then the name of the file that you want to assign when you copied it to that machine, and then press enter. Now if you want to restore, you already copied it to the PC, to the TFTP server. Now you say, well, now that my router crashed, I don't have the running config, I don't have the startup config, but I have it backed up in my TFTP server. How can I bring from the TFTP server now back into my router or back into my switch? That's when you do just copy the command in the other way. Now type copy TFTP running config. See, before what you did copy running config to TFTP, and now you're going to do copy TFTP into the running config. Okay, so it's going from the TFTP, now it's going to come back to your running config. Interesting. And you do the same thing, put the IP address, name, and everything. Simple. Next, you can also do using USB ports on a Cisco router. You can also back up. You can also back up your iOS, back up your NVRAM, like the startup config, your running config. So you just put a flash drive on this USB port. Cisco router, some of the Cisco routers have this feature. They have this USB port. So you put your flash drive, pen drive, whatever, thumb drive, whatever you call it, in here, and then copy your iOS or your startup config or your running config to the flash drive. Okay, I'm not going to go to too much detail on the steps on it. Very similar. It's a copy, then run or running config, then USB flash. Last time we did what? TFTP. Remember, run is same as running config. Then you did TFTP. This time you're doing USB flash. Very simple. Okay. And when you want to restore, bring it back from there again, then you do what? Just the other way. Copy, then from the flash drive, USB flash to the running config. That's it. Whatever the file name, this is the file name that you saved as. And now that's going to become your running config. Okay. So next, password recovery. Password recovery is important. Sometimes we might have forgotten password in our router or switch or anything, any device. So there is a way to go around. Once you lost your password, you cannot go into the privileged exec mode anymore. You cannot change anything anymore. You're locked out. That's it. So what you do, there is a way to go around and go to the privileged exec mode and then set new password after that. Okay, there is a special little software in the firmware of the router called ROM or ROM monitor. So that ROM monitor is where you need to go. So what you do, you just turn off the router, turn back on. Once you turn back on, then you need to go to the ROM monitor mode. You press Control and break. On the keyboard, there's one key. It is like pause and break, that key. So you press the control key and you press the pause and break when router is booting. Okay, then you're gonna interrupt the router's boot. Okay, then it's gonna bring you to the ROM-mon mode. Normally it's gonna be this ROM-mon 1. In the ROM-mon 1, you type this command config, meaning configure register. Okay, 0x2142. I want you to know that two kinds of register that you can have. Okay, 0142 and 0102. Look, this 0x2102, 0x2102, that is one. Another one is 0x2142. Okay, I want you to know this. Let me just write down here just to clarify. How the router boots, you can dictate that. Normal is 0x2102. That's your configure register. Okay, your register could be set as 0x2102, or it can be set as 2142. Okay, just remember that. This one 02, that is normal boot. So that's where we always have normally all the routers and switches set up. Okay, it's going to be boot normally. And normal boot means what? Loads the startup config. Okay, it loads the startup config. That's the thing. Startup config file is going to load. Okay, and once you have this config register as 2142 instead of 2102, you got 2142, then you are in the password recovery mode. Okay. Okay, and it will not load. It will avoid. It will circumvent. Okay, it will ignore or avoid the startup config. Okay, so config register, I can normally it's always set as this one, 2102. So when we want to do password recovery, we need to go, we cannot have a normal boot anymore, because if it normally boots, it's going to ask me for the password. So what I'm going to do, I'm going to go to the ROM-mon. Okay, first, again, step number one, before I can even type this, before I can even change this, first thing I have to do is to go to the ROM-mon mode. So the first step is go to the ROM-mon mode. Okay, and then you do this. So this is the normal, and set onto this one. Okay, for password recovery, set to this one, change to this one. If you want to do password recovery, normally it is like that at all time, unless you go to the ROM-mon mode and type this command config 0x2142. Okay, so then what's going to happen is going to bypass. It's going to bypass the startup config and take me into the router. So I'm going to be in the privileged exec mode. Then I can set the new password and everything. So let's go back to the chapter. That's why they did this ROM-mon. How did they do the ROM-mon? How do you connect to the router, by the way? In real life, you don't have packet tracer. Packet tracer is just a virtual thing. That's not real equipment. In real life, you need a laptop or a PC to connect to a router, right? In that laptop or PC, you need some software program installed. That's called PuTTY or TerraTerm, some kind of software. Just say like PuTTY software. So then you're going to open up that PuTTY software, and then you turn on the router, plug in your cable to the console port. That's how you go to the router, right? So in that PuTTY software, you're going to see that the router is booting. So as it's booting, you have the PuTTY on, you're seeing router is booting. You see that screen. That's when you press the control button on your keyboard and your break, control and break key. Okay, there's a key again that's called pause/break, that key. So control break, that's when it's going to bring you to this ROM-mon mode. Okay, then in the ROM-mon mode, you're going to type this command config, meaning config register 0x2142. That's the password recovery mode, and that's it. You do the reset. Once you do the reset, then it's going to come back in a it's going to let you go to the bypassing the startup config. What's going to happen in that is going to take you directly with a blank startup config, blank running config, no running config, nothing. Okay, the startup config is still there, but startup config has not been loaded to the running config. That's why, remember, running config is temporary. When startup config loads into the RAM, that becomes the running config. You turn off the machine, there's no such thing as running config. So in this case, running config is not there, because startup config has not been used, has been bypassed. So you are in the router privileged exec mode. So then you type this, copy startup config to running config, meaning bring the startup config now to the running config. So now I have a running configuration file that is up and running, and it's not going to be affecting you because you already bypassed the password mode. You are already in the privileged exec mode. So now you have the running config. Then you go ahead and put the new password, like enable secret this config. So once you put the new password and everything, save it. Then you just type config register again 0x2102. It's normal config register. And that's it. Copy the running config to startup config and reload the machine, and you're done. Okay, so what you did, once you are in the, I'm repeating, once you are in the privileged exec mode, you first copy the startup to running, meaning bring the startup config back to the running config now, so I can have a file to work with. In that file, you're going to put a new password, enable secret, a console password, whatever, all the password is changed. After changing all the password, then you set back the register again to 0x2102, and then you copy this running config back to the startup config. Now the startup config has the new password and everything, and then you just reload and you're good to go. Okay, so they're just teaching you these things here, so just go ahead and learn these things by doing these commands. Okay, next. Now packet tracer, backing up configuration files. What is a configuration file? Again, running config and startup config. Those are your configuration files. You can back up. You can back up to a TFTP server, back up to the USB flash drive, back up, to wherever you want. So those kind of options are there. Okay, now let's see. Now, the image, what is image? What are you talking about? Image means your operating system. Okay, the iOS image, that is your internetworking operating system. The Cisco router or switch runs on that operating system, like your PC is running on Windows 10. Your Cisco is running on your iOS. That is the file that you have to load, that .bin file, that is the iOS file. That file is called that iOS image. Okay, so you also need to know this word, the integrated service routers, ISR. ISR stands for integrated service routers, and G2 means generation 2. Okay, generation 2. So ISR G2, that means integrated service routers generation 2, and those routers have this iOS file. Okay, that file, as I mentioned to you, that file has many sections. It's a long name for that file, right? It's going to say C1900 universal K9. What does all those things mean? Okay, we're going to learn a little bit in the coming somewhere in the coming slides. Okay, but right now what we're discussing, that this universal K9 part. Okay, so it's a designation. Either it's going to be universal K9 in the name of the file, iOS file, or it's going to be universal K9 NPE, this one of the two types. And they mean something that either for the exporting to other countries, some less encryption, not too much detail I want to go on that. I'll just move on to from here. Okay, but now this is something we want to learn. C1900, universal K9, MZ, SPA, 152, 4, M3, bin, the whole name. We want to know what all of those mean. Okay, look at this. C1900, the first thing that is right here, that shows the hardware platform. What kind of router? Meaning all the Cisco 1900 routers, this will take this iOS. This iOS is made for this C1900 series routers. What does the universal K9 means? It specifies the image designation. The two designations for an ISR G2, integrated service routers generation 2, second generation, either universal K9 as I mentioned, or universal K9 NPE. Universal K9 NPE does not contain strong encryption. That's the thing. If you want strong encryption, you want to have this universal K9. If you take this other file, you can download this file also from Cisco's website. If you want this NPE, it will not have strong encryption, and is meant for countries with encryption restrictions. That's why. So in the United States, you would like to download and install universal K9, not the NPE, onto your router. Okay. Then what does the MZ mean? Okay, well, M means memory and Z means zipped. Okay, what is that for? Meaning this file would run from the memory, from the flash RAM right here, RAM. Okay, and Z means this is a zipped file. It's a compressed file. So let's read it. Indicates where the image runs and if the file is compressed. In this example, MZ indicates that the file runs from RAM and it is compressed. Okay, it has to be uncompressed. Remember when the router boots, you always see this pound sign keeps on going and say uncompressing the file. Okay, that's what it's when it's uncompressing. What does the SPA stands for? Designates that file is digitally signed by Cisco. Yes, it's carrying digital signature. It's authentic. And these are all the versions. Okay, 15.2, all these are versions. Okay, let's learn more. Each one means something. This 15 means version 15. Okay, so right here, this is the version of the iOS, which includes the major release. 15 is the major release. Version 2. Then the minor release would be 4. Maintenance release is M3. Okay, and maintenance rebuilds number 3. The M indicates the extended maintenance release. So it's way too much detail. That the major release, then the version, then the minor release, then the maintenance and the maintenance number. All those. These are all version. And of course, .bin is the extension of the file. This extension indicates that the file is a binary. It is a binary executable file. Okay, so just know. And remember this MZ. MZ means M for the memory and the Z for the zipped file. Instead of M, you could have F, you could have R, you could have L, relocatable. No, don't worry about that much. Okay, move on. Here, I want you to pay attention, because these kind of questions, sometimes in the CCNA, these kind of questions could be your final exam. So learn this. The same thing that I just discussed, just at home practice more. This is the hardware, this is the image designation, this is the memory location, this is zipped file compression, all those things, same thing. Okay, so it's good to have, practice them all. Okay, now TFTP server as a backup location. As I already discussed a little bit earlier, that your iOS, this is your iOS operating system file. Can you back up this operating system file onto a TFTP server? Yes. All you need is a TFTP server setup. Remember this TFTP D32? That kind of software, free, you download, install in your machine, repeating basically. Make this a TFTP server, assign an IP address to the server, and then you copy your, the file, iOS file into that server. That's it. How do you do that? Let's see. It may show you right here. Yeah. You are first trying to make sure you're in the Cisco router. You're trying to make sure that you can access the server. You have the connection. Just ping. Oh, okay, I was able to ping. So good. From the router, I have the connection to the TFTP server. Just basically a PC in your network. Then you're going to see, let me see what do I have in the flash memory. You type show flash. You said, oh, okay, I do have this file. That file is my iOS file. Okay, I would like to make a backup of that file. I would like to make a backup of that file to this machine, 172.16.1.100, to that TFTP server. How do I do that? Next. You just type copy, then flash, TFTP. That's it. Simple. Same kind of copy command. Copy, like you did copy running config, startup config, those things. Copy running config TFTP. Now you're doing copy flash 0, because flash could have flash 0 or flash 1. You have two flash memory slots in the back of the router. So you have the flash 0, and so in there, from there you saw that your flash 0 has your iOS file. You're copying to the TFTP server. Then it's going to ask you, hey, what is the IP address of the TFTP server? What is the file name? All those things. So it shows source file name. You got to type up this file name exactly, or copy and paste. Then address of the remote host. Remote host means the TFTP server. Type that address, IP address. And then destination file name. The destination file name, it will already write down the same name for you. You just press enter. And then it types. That's it. And you can restore it back from the TFTP server with the typing the command copy TFTP flash the other way. That's it. Okay. And those things it shows here. That first you wanted to make sure that you can ping to the server. It's good to do. Okay. If you already know that I know that I have connectivity between my router and the server, you don't have to do the ping. Ping is just to check and make sure that you can reach the server. And then you make sure that your iOS is in the flash 0 or flash 1 or whatever, and then you do the copy command. That's it. Next. Okay, iOS, same thing, ping. This time we're using a IPv6 address instead of IPv4 address for the TFTP server. Same thing. Okay, same kind of stuffs. Boot system command. Boot system is another command that if you have more than one iOS image in your flash memory. Now, say you have this 15.2, that one. Then you downloaded 15.3, a later edition, more upgraded edition of the iOS. But how do you tell your router that, hey, I have two iOS files in my flash drive now, but use this later one, use this new one to boot? Okay, that's when you use this boot system command. With boot system command, you tell the router which iOS file to use to boot with. Okay, so this boot system command. Okay, so now what is the show version command? Show version command, that command shows all about your hardware information, your memory, your RAM, your software, your iOS, your everything shows in the boot show version command. Okay, it's very important command, show version command. Okay, background scenario. Okay, some video. It just shows how you can manage your iOS, how you can download an iOS and install in the TFTP server, bring it back to your flash drive. How do you use the boot system command to tell your router use this new iOS file? Just watch the video at home, not a problem. I'm not going to discuss the licensing, Cisco client license, how to buy license and how to use the license. I'm not doing that. Okay, install license. Okay, backup license, I'm skipping that one. Okay, and that's it. That's your end of the chapter 10. So I hope that this chapter had too many small little points. It helps you. I hopefully you all are, so basically we're done with all the chapters. From now on, I guess as early as tomorrow on, I'm gonna start doing labs big time for you. Whatever labs are left, I'm gonna finish up all the labs for you so that you can do all your labs. Okay, and I'm going to also remind you, send you probably an email reminder that tomorrow is a Sunday, but not tomorrow's Sunday. Sunday the 10th, Sunday the 10th of May, you have a deadline for all the remaining labs. That's like 10 labs and like 5 chapters. All the chapter exams, all the labs, your deadline is Sunday, May the 10th. So I want you to know that. Okay. So get going on all of those, and then we're going to only have left what? The skills exam and the final exam. Okay, we'll talk about that later. First, finish up all the labs and the chapters. So let's see. Where do I go to stop recording and stop streaming? Okay, end stream.